Hey everyone, happy Friday. Thanks for joining. This is the Voice plus Robotics Twitch stream. I see we have ice cream codes and maybe a few more on here already. So hi and happy Friday, welcome. Thanks for joining. We'll get started here with a little overview. We've got a lot to get to. Let's see, make sure my camera's going for you there. Let's see if we can see Robot Cam first because we're gonna wanna look at the robots some today. Maybe not. There we go. Hey Jenny, how are you? Thanks for joining. All right. It looks like my camera's not working, so we may do without my camera for today. Let me see if I can get it fixed really quickly. While I'm doing that, let me explain what is going on today. So today we're going to look at adding, I'll go to Robot Cam here, adding recognition or adding video to the Raspberry Pi and the Create 2. So the Create 2 is the Roomba version of, or it's a Roomba clone, I guess you could call it. It's a programmable robot that you can get from iRobot. So we've been using that for the past couple of weeks to get some more functionality added to it. So today we're going to work on vision. So one of the things I want to do is get some person recognition done, then also some object detection. So once we get object detection, we should be able to go through and navigate through all of the, like a house or any kind of environment that we're in. So we'll work on that. It looks like my camera's not going to work, so you will get to just see the screen today. All right, so what we're going to use is Amazon recognition. So let me show you this. If you haven't seen recognition, it's pretty cool. Actually, really cool. But it takes so much of the effort of building your own recognition into a system. So there are a couple ways to do it. So you could have everything on board. You could have everything living on your device. So in our device, in our case right now, it's this Raspberry Pi, but it could be any robot, it could be any other type of controller like this, like an Arduino or a Jetson. So you can have all that living on the device, which is good. It helps you with latency. So if you want to have a real low latency image detection, then you might want it to live on the device. But even using something like recognition is really fast. So I'll show you how fast it is and kind of what it can do. Let's just see if we can find a quick demo of this real quick. I think they have a pretty good one right here. Well, we'll go to get started. So let me sign into my account, and I'll just show you what I have set up, and I'll show you what I've done so far. So it can do object detection, it can do facial recognition. So I want to show you some of the facial recognition that I've set up. Let me log in here. Okay, let's go to recognition. Okay, so this is object and scene detection. If you go to recognition in the recognition console on AWS, you'll see this. This should give you an idea of what it can do. So here it's detected a person. It's detected I don't think it shows a skateboard. Yeah, it does. Skateboard with 94.3% accuracy. It gives you nice bounding box dimensions. So if you want to draw your own bounding boxes around things, you can do that, which is pretty common. You can also upload your own. I'm not going to upload my own just yet. I'll just show you one in real time. So I'll show you what facial analysis looks like. So you can take a picture that has a face in it, and you can see that it gives you some metadata like this. So it looks to be a face, it appears to be female, it gives you an age range, things like that. We're going to use it for recognition, for our own recognition. So out of the box built in, AWS recognition or Amazon recognition has celebrity recognition. So here's Jeff Bezos, here's Andy. So it'll give you a lot of celebrities that are built in that can detect automatically in your images if you needed it for that. But we're going to need it for something else. So let me open this. So I will open, let's go to my facial recognition. I think this might be it here. Nope, we find it. Let's see. Still looking. Twitch stream code, stream server, Twitch robot, not it. Where am I missing this, guys? Can someone see anything that looks familiar? How about create demo? Nope. Create demo. I think I can find it better like this. Okay, let's see here. Robot cam maybe. Not it. So we were playing around earlier this week. If you want to join the stream where we kind of do some behind the scenes things, you can join twitch.tv/jbnunn, you'll see some of the behind the scenes things where I build things like facial detection. Create demo, create object detection. Well, I don't know where this is right now, so we're going to jump to the other part of the demo, and I'll come back to this one. So let's go ahead and SSH into the Raspberry Pi. And what I'll show you here is the Raspberry Pi, if you remember on the robot cam, is built in here. And now, since last week, I've got a camera attached to it. So this camera comes from this cable down here, and I've got it mounted to the front of the robot. So now, when the robot's navigating, we'll have a camera at the front of it. So let's go to Twitch Robot. And again, this code is all available for you right now. So if we go to GitHub, you can have all this code up to the point where we are today. So all of this code is here. It gives you all of the steps, and I've actually lined out how long it will take. So there are some things here that take a while, especially, especially this part. This one is the hardest part. But then the rest are relatively straightforward. So there's step-by-step readmes for all of this to get you to the point we are today. And then after today, what we'll do is I'll post the rest of this code for you. So let's see what we've got here. This is, all right. Let's go into our Create Workspace. Let's go into Source, Alexa. Now, if you remember from the first episode, we have a listener called listener.py. So listener.py just listens for voice commands on the device. So the device is listening for voice commands. When we say, Alexa, ask Twitch Robot to move forward, the device moves forward. You saw that in episode 1. So back here in the code, we'll go to that, and let me open up Code Insiders so we can have a nice GUI version of it. Oops. I switched today to this light theme. We'll see if it looks better for you, and I'll blow the font up so you can see it too. All right. So let's go to Alexa source, and then we'll go down to listener.py. Okay, so here is listener. So all listener does is listening for a topic. So it's listening for anything on voice drive. When it sees something like go forward or spin, it's going to drive forward, spin, or stop, whatever it might be. So today we're going to add a new topic. We're going to make a topic for the camera. We're going to call it, let's just think about the topic. We'll call it camera, and we'll issue a command to the camera. So today it will just be take picture. Next time it might be take video. Next time it might be recognize people. Well, actually, we'll get to the people part today. So let's add a topic there, and then let's go ahead and subscribe to the topic. So I'm just going to copy this code we use for drive. We're going to do the same thing here. We're going to add a new topic called camera. We'll make a new callback called camera callback, and we're going to just output that we're listening for that. So we're listening on camera. So let's make a new callback. We're just going to copy the drive one. Since that one works and we know it works, we'll call this camera callback. Okay, so we receive a message. We get the payload. We get the command. So our commands right now, we're just going to say if command equals take picture, let's take a picture. And then else, we're just going to say that doesn't exist. Print command doesn't exist. Okay, let's figure out this take picture method. So let's go, we'll just add it right here for now. Def take picture. Okay, so what we want to do is we want to use the Pi camera module. So let me grab that. I'll show you where that is. If you have a Pi camera at home, you can do the same thing. So Python Pi camera. I think that's all we need to type to get to it. Yeah. These recipes are really helpful. So it comes with some default sample code, and we'll use this. We'll use some of the sample code. In fact, we want to capture a file. So the idea for us here, let's write some code here. Or takes a picture with the PyCam. Take picture, save to file, upload file to recognition, and look for people. Let's do step 4, look for people. So this is the goal for today. We're going to figure this out in the next 45 minutes. Hi, E. Hernandez. How are you? Thanks for joining. All right, so take pictures. So the first thing, let's go back to the sample code. Let's grab, I know I already have time, so we're going to grab Pi camera. I'll go ahead and grab this while we're here. Brings it to the top. So usually you sleep, when you initialize the camera, you want to sleep for a couple of seconds in order to let the camera adjust to the light. It's just a best practice. So I'm going to keep that here, that's fine, but I'm going to move the rest of this code down. And we'll move this here. That's fine. We'll give the camera a chance to wake up. And now we'll come back here and start this. Take picture. All right. So camera, let's close this comment out. Jeff, are we working with PubSub? We are not, let's see. Yes, we are doing PubSub today. So PubSub is today. So we're going to PubSub. We're going to send a publication to the camera topic. And then this file right here is listening to camera. So once it sees a command from camera, it's going to take this picture. All right, so file name. Let's make a new file name. We don't want to call it foo.jpg every time. We'll call it time.time plus, that's actually probably perfect. File name plus JPEG. That's the file name. So we're going to capture whatever the camera sees to this file name. So that's it. That saves the picture. So that should be take picture, done. Save to file, done. Upload file to recognition. Okay, so we need to do that. So let's, we'll just do it. We'll do it all in this method. I think I'll clean this up for you later and have a nice package that you can look through and have more comments. But since we're going to kind of go fast, we'll go this way. All right, so save to file is done. Upload file to recognition. So let's get some source code for that. So we're going to look at the Boto 3. That's the Python library. Boto 3, Amazon Recognition API. Okay, so detect faces. I know so I'm looking for faces. I'm sending this to recognition, and all I want are faces. Let me show you a little bit how this works. So when you create in recognition, you need a collection. So if you want to do custom pictures, you need a collection. So let's look at this first. Recognition. I know I'm spelling it wrong. Create collection. All right. So the collection is a collection of faces, and what it does is it takes any image you give it, and it analyzes it for key points, for regions of interest, all of these little metadata variables that it needs to create a digital or a binary representation of the face. And so then we store that in DynamoDB. So then we have a whole list. I'll show you my DynamoDB. I go to Services, Dynamo. I have a list of recognition, family, and friends. So I've only uploaded myself and my son right now. So these are all of our virtual image, our images that have been made into this. Let me show you what it looks like. We get a full name, we get a string. Oh, so what happens is it stores on on Amazon servers. So it's just a key that references the data. It doesn't associate it with a name. I have to do that myself. So all that the Amazon servers have is this big blob of data. We have to associate the name with it. All right. I actually think I remember where, let's see, let's go back here. I think I remember where my indexer is, the indexer that made the collection and all of that. So let's just look here. Maybe not. I want to show you how it does detection on the faces that I've already added, but that's okay. We'll just add it ourselves if we have to. I don't think this is it. Whoops. Okay, that's not it either. Oh, I'm back in the Raspberry Pi. This is a fun one today. Can't type. But it's Friday, that's the good part. All right, let me see. I'm going to take one more look here. Create autonomy is not it. Create demo might be it. But I think it has the word image or robot cam. It's not robot cam. Behind the scenes noobs. You guys are no noobs, that's for sure. All right, I'm gonna try one more time. iRobot create. Let's see if it's in here. Nope. I'm gonna try this one more time. Open recent. Create object recognition, demo, robot cam. This doesn't look like it. Oh, it is it. Okay, perfect. So these are my kiddos. This is a picture. You can see I'm going to delete this one that's already been annotated. So we're going to delete that. These are the kiddos. I'm going to open a terminal. And what I did to train, so let me run this first. So I'm going to say Python vision.py, and I'm going to give it a file name of cap.jpg. All right, so what it did is it took this picture, it sent it to Amazon Recognition, it looked for faces, it gave me some bounding boxes. I'll show you what happens. So it comes back, too big, there we go. It comes back, it looks for faces, so there's the detect faces API method. Once it finds it, it gives me bounding boxes for left and top of all the images and the width and the height, so I can draw boxes around any face I find. So what I do once I get those faces, so it just gives me, it says, hey, there's a face here, I don't know who it is, but here are the XY coordinates of the face that you should draw or should look at. I take that, I send it, and I give it a collection ID, and I say, okay, out of all the faces in my collection, which again, that's family and friends, I want you to tell me who this person is. And then what I do at the very end, I just write a new file called annotated. So sit here, let's see. Oh, that's me and my son. Let's see where it spits it out. I'm not sure if it's detect faces. Here we go. So somewhere in here it will save it for me. Annotated image is what we're wanting to save. And we're saving annotated cap. I'm just not sure it's saving that. Let's try, oh, Hank Jeff, okay, it did it. So I don't want to do that. Let's do cap.jpg. There we go. I don't have the arg parser there to get that cap.jpg. So this part doesn't matter. So this is what I've got here for you. It's pretty easy. I'll add that to the repo too so you can see it. It's a little easier to see it. So annotated cap is a new file. You can see that I haven't trained it on my daughter at all, but I trained it on my son, so now it's got Hank none. So it shows a nice picture of Hank. All right, so that's that. This indexer is how you train it or how you add things to the collection. So what you do is you give it a list of faces, a list or a directory of images. So I had 12 for my son, I had 16 for me, and I trained it by just giving it a list of images, and then I just let it iterate, and it adds it to the collection. That's all it's doing. It's actually adding it to S3, and then S3 has a Lambda function that adds it to a collection for recognition. All right, so that's how you train it. So let's go back to this. So we're capturing the file. Now we're doing the same thing here. We're capturing the file, and we want to send it to recognition. So let's do this. All right, so let's think. We've got to go back to our API because I don't have this memorized for sure. We want to search faces by image. So we have all of this. Collection ID and image. Okay, we're going to copy this. So response equals client, and so client right here is going to be client equals Bodo3 recognition. All right, search image by faces. Max faces, we're just going to say 10 for now. So if you had a room that the Roomba was running through and it had a camera on it and it took a picture of everyone, maybe you don't want to have all the faces, so we will do that. You also get a threshold, and I'll show you the thresholds in a second when it looks for faces, but you'll get a threshold that will say, okay, this is a 80% match. So if you want to throw out anything below 80, you can do that here. I don't really care about that right now. All right, search by image, max face is 10, and that's it. Let's just print the response. Let's see if we can get lucky in the first try. So let's change a few things here. Collection ID is going to be friends. No, it's actually family and friends. And if you can't remember your collections, just use the AWS CLI, AWS Recognition list collections. So these are the ones I have so far. You can see I have some RoboMaker ones, but then family and friends. So that's my collection. Again, that's just the pictures of Hank and I, my son and I right now. Jeff is trying to make it easier. Oh, what? White ID. Do you want to go, you guys want to go dark? Look at it. I've got all sorts of fun ones. I'll keep an eye on comments. If you want me to go back to dark mode, let me know. All right. Bright pink. You work on that one, ice cream, and I'll install it next time. How great would that be? All right. So bytes. So that's looking for bytes. We're not gonna. So you could also upload it to S3, or you could just give it bytes. We're gonna give it just raw bytes. So in order to do that, we need to convert this file to bytes. So we need to do this with open file name. We want to open it in read-only mode, and we want to open it in binary mode. And we're going to give it a, let's say, as image. Move all this over. Move this over too. So we're opening the file that we just saved right here. We're going to open it. It's going to read it as binary, as bytes. And we're going to say bytes are images, or image, right there. All right, so what am I missing? I'm missing something here, probably a bracket. Nope. That's that. That's that. Should be it, right? Maybe that was it. Okay. So let's try this and see what happens. Python. Well, actually, before we do that, we need to. The only way to invoke this picture is to do pub/sub. Oh, Boto 3 we don't have. Let's go add this real quickly. Boto import Boto 3. Look at this. There's another mistake. Time.sleep. All right. So that's good. No errors. So now we have to send a message. All right. So camera, and we said take picture was going to be the command, right? So when we run listener, it's going to initialize these callbacks. It's going to listen to camera. And if it gets to camera, we're going to look for take picture. So let's get ready to run that. So let's say Python listener. Oh, let's go to the right directory. Create workspace, source, Alexa, source, and then, I haven't seen that error before. CD create workspace. CD, oh, I hit Python. All right, I see what I did wrong. All right, so here it is, and then Python listener.py. So we should see listening on voice drive and listening on camera. Remember it. Oh, we need to run the node. So remember with ROS, you have to run a ROS core. So what I'll do is I will SSH into the Raspberry Pi, and we will run ROS core. Right here. So I'm SSH into this. We're running ROS core. All right. Blow this up a little bit so you can see. Actually, it doesn't matter. Just telling you that it's running if you can't read that. All right. So we're going to close listener and restart it. All right. So now we should see listening on voice drive and listening on camera. Huh. Still can't find it. Let's see what's wrong here. Oh, I know what I did wrong. We have to SSH into SSH Pi at 192.168.86.25. All right, so I was not on the Pi when I ran ROS core. Now we should be good. Few lines covered. Oh, sure is. I can fix that. Give me a second. I'll try to keep everything up kind of high in the code too. All right, a little better. Good. All right. Listening on voice drive, listening on camera. Cool. So now we're listening. So let's go send a message. So the way we can test these messages is we'll go to the IoT core. And we're going to go to test. So remember, if you missed episode 1, what's happening to be able to communicate and do pub/sub? We've got certificates that live on the device and live here in IoT. So as long as they match, you're going to be good. So we're going to say we're going to post to camera. We're going to send data that says take picture. And I know you can't see that. Let me move this up too. There we go. And I'll increase the font. All right, looks good. Publish the topic. So when I publish this, we publish. Let's go check it out. See what we got. Whoops, I don't want that. I want this. Type error, unsupported operands. Okay, so we just need to change this time. Our file name is not right. Easy fix though. We'll go to file name and make that a, whoops, we want to do time.time is a string. I'm curious why this Boto 3 is still, okay, took it away. That's good. Try it again. All right, listening on camera. Let's publish the topic, take picture. Let's go back to this. Module is not Boto 3. I did type something wrong here. I think it's client recognition. Yeah. All right, trying again. What do you think? Any mistakes? It's going to work? All right, cool. We're closer. So let's see. We definitely got to line 85, which is in our method, I bet. Nope, not yet. Let's unsubscribe. Okay, faces. Max faces 10. It didn't like that part. So line 74. Let's take it out then. I want all the faces. All right, so is anyone seeing a use for this yet? So I know definitely for object detection, I can use object detection to find points in a house or an environment and then navigate around those. The robot does come with bumpers on it, so it does come with physical sensors, and I've got an ultrasonic sensor I'll add. But I'd love to hear your ideas for person recognition. So you've got those to them in the chat too. All right, so we're still having a little problem here. So IO buffered reader, a bytes-like object is required. I'm going to shrink this font just a little bit so I can get, there we go. I can read a little better. All right, so line 72, take picture, bytes, image. So it just doesn't like this part. Open file name. We definitely saved it. Looks like it is too small for you when I do that. All right. So let's copy this error. We'll find the answer. Oh, so it's getting a string maybe. Open file name, read only binary as file. Maybe I have to, okay, let's try this. Amazon recognition. Recognition for some reason, oh, I spelled it right, I think. It's tough to spell with that K for me. Analyze an image loaded from a local file system. Okay, this is probably what we want. Python code is good. So we're opening it. Oh, image.read. This is the part we missed. So image.read. That will read into a byte array. So now we're getting the bytes. And the response, this is going to be fun. We'll go ahead and copy this. This might be actually good. I'm printing the response anyway. Let's see what it looks like. All right, so some, let's see, Serg, detect markers for zones which should not be clean and trespass. Yes, that'd be good. There are virtual walls you can get for these Roombas where it sends out an IR signal, and the Roomba that we have, the Create 2, does have an IR reader on it, so we could use those too. But I like that, so I think what we could do is just, we could do edge detection to find walls and find pieces that we didn't want to go near, or at least stop when we got to. That's a good idea. All right, so IoT, publish the topic, take a picture. All right, so we got that. There are no faces in the image, right? All right, that makes sense because the camera is moving, or it's not moving, but it's pointed away from me. So I'm going to set this up where it's actually pointing at me. Vacuum cleaner, recognize doors to leave the room only when complete. Ah, I love that. That'd be good. Or you know what'd be cool is if it looks into the room and sees, I don't know if you can see me or not, this camera. We're going to find out. So I have the camera pointed right at me. But what if it sees a person in the room and then it doesn't go in there? That might be nice too. All right. Let's try this again. No faces. There should be at least one. That's pretty cool. I like that. In the good code that I clean up for you later, I'll add a guard for that. So in case it doesn't find pictures, it won't fail ugly. Does everyone understand what's happening with listener? How it's working on the pub sub? All right. Let's see. Take a picture. Let's go back. No faces. All right. I'm gonna lean way. You know what? I wonder if let's do this. Camera. I know one thing is camera dot. Is it rotation? Yeah. The camera by default is not. It's turned upside down. So let's try that and see if that helps. I don't care about preview because preview is only if I'm going to look at a screen. So everything is better there. It looks like. And then on this next one, I'm going to lean down kind of right into the picture and see. Push it back a little bit. I need a camera at work so it sees my boss, minimizes and mutes my Twitch browser. Yes. Boss detection. Love it. Okay, here we go. I'm gonna scoot down. I wish my other camera worked so you could see me contorting here, but publish. All right, I was looking directly into the camera. Let's see what happens. There we go. So cool. Look what happened. So it got a face. It got a face ID. So let's go. And it gave me a bounding box. So here's the width of the bounding box, the height, the left top. So this is how you would draw a rectangular box around it. For now, let's look at this face ID. Let's go back to DynamoDB. Open a new tab. And let's just see. I already know it's going to be here because it found it. But we'll look and I'll show you. Family and friends, item, and let's see. Do I have to 1 to 23? We want oh, actually, I don't know if this is what I want. Recognition. Yeah, it is. String ID equals that. Maybe it's not. What did I get wrong here? Oh, face ID is different than recognition ID. That's okay. So now that we have this, all we have to do, we have faces. So we're going to say if, I think it's called matches here. Let's see. Face matches. All right. So if response face matches, we'll say length of it, greater than 0. Now we're going to go. And then we're going to say else. Print no face detected. Okay, search faces by image. Now let's see. We want to let's do a DynamoDB lookup now, right? So analyze an image. So here's how we'll do object detection. You can actually take the same code and do detect labels, so it'll detect things like animals, water bottles, table, chair, skateboard, etc. All right. Let's go with, in the interest of time, I'm going to search for this instead of kind of looking through all the documentation. So Python, let's actually do Boto3 recognition, search Dynamo, let's just say DynamoDB. Let's see if we have some good sample code. All right, so search faces by search faces collection. This is what we want. Here's our face ID. Here's what we want right here. So I'm going to copy. Did I already add collection ID? I'm going to take this anyway. I'm going to copy this. We're going to paste this here. Okay, so collection ID again. I think I have that. Did I? Yeah, family and friends right there. But we'll just go ahead and double it. Threshold's 50. I'm going to say I only want anything over 90. So you can see like confidence 100. So it definitely finds me. So we'll say anything over 90. Max face is 2. That's fine. Face ID. Okay. So we're going to say for face. Did the sample code have this already? For match and yeah, here we go. This is what I want. I see. It's already happening here. Okay. So I want bring this here. Collection ID is that. Family and friends. Okay. Matching faces. I think this will work. I feel like I copied. Yeah, I think that works. All right. I'm going to close this and restart it. Oh, great. Start if you get to meet Mr. Cutsinger. That'll be fun. Oops, I wasn't looking down at the camera at that time, so it may not come up with a picture. Yeah, let's try again. Really glad you can't see me cheesing at the Raspberry Pi. No faces again. I wonder if get really low. Okay, that should have got it. Get out of here. Still no faces? Maybe we need to restart. So sometimes, every once in a while, especially if you have, okay, there's some errors we need to fix anyway. All right, good. So you just have to wait for that unsubscribe timeout exception to happen. Okay, let's make sure this is right. I'm going to shrink the code because I still can't really see it. I'm not used to working with this. Show the picture that captured. Oh, you have to pay me for that. That would be crazy. I'm not showing you me contorting into that camera. Let's see. I could show you. Let me show you. Maybe. Well, if we have time at the end, I'll show you. 20 minutes. I'm going to knock this out in 20 minutes. I'm going to do some fast coding. Get ready. All right, so we've got our collection. We've got a response. If the responsive matches is greater than 0, then I'm just going to move this up here because it's driving me crazy there. Family and friends. We're going to call this collection ID. There we go. We have that. All right, so this is a new response. We're going to say client response. We're going to say search response. Search response equals search client, which is right here. That's good. Face ID. So this is actually going to be, let's go look at this sample code. All right, this is going to be response for match in response face matches. Let's do this. Let's move this here. Face ID is going to be match face ID. Not quite sure that's the right variable, but we're going to go with it. Match threshold, I'm just going to hard code that to be at 90. Max faces, I'm going to leave out. And we're going to close that. All right, I do want to print, let's print response face matches, just so I can make sure, because I don't think face ID is the right variable I need. Oh, here we go. Here's everything I need. There we go. This is going to work. So let's run this. It's required for your job. Oh, sorry, you're saying Lynn right here? We're just saying, if you're talking about this part, it's just making sure that we have some face matches. Did I have something not closed? I misspelled that, that's for sure. Close this and restart it. So if the length of, so if we have enough face matches, oh, I see what you're saying. Maybe we need this. We need that, okay. And we're going to print them out. We're going to load this client. I don't want to load that every time. I'm going to put this up here. I already have it. That's good. Okay. We're cleaning up. So we're looking at the response. We're getting the face matches. We're looping through face matches. We're getting the ID. We're going to print the similarity. So you should see a lot of Jeff Nuns, I would bet. All right, here we go. Gotta shrink down. All right, took the picture. Oh, come on. Still no faces. Now we have to wait for this fun timeout. Okay, once it's done though, we're going to have, we'll be really close to being done with this. All right, here we go. There we go. So here they are, match face ID, good. So these are all the matches and they're the IDs of the face. So what we want, let's see, does that show up in Dynamo? Items, recognition ID, okay. So now we just want to look those up. So let's look, I bet we have some sample code right here to do that. Search faces by image collection. Search faces by image collection. Okay, we've got that. Really, we just need a Dynamo DB. So let's see. We're calling this what? Search faces by image. Definitely getting matches. Dynamo DB read. Can you pair program with Jeff every week? Yes, please. We'd save so much time on these little tiny typos. All right, this looks like a good blog post. So this shows you how to create a collection. So this is what you would do to start. And then I will post, remember I'll post this indexer. So this indexer is pretty straightforward. You're just going to upload things to S3. And then I've got a Lambda function that actually looks for, this may not be it, but it looks for the, it looks for updates in that S3 bucket and it adds it to your collection. So this will show you how to do it. But we want the code, the fun code, that will tell us who's in the picture. Here we go. There we're searching. Enhancements we don't need just yet. So this is for how to draw boxes. Okay, this doesn't do it. Well, I think we can just do it ourselves. Let me see what the output was here. Okay, so similarity, bounding box, height, face ID. Face ID. We'll search. I'll pair program with you anytime. So let me know. It'll be fun to try one time. Might even try it for some of your ideas there. All right. So what I'm trying to do is just look up. I want to find this face ID. Let me go back to my. Let's go back to this code sample. Recognition. Look up by face ID. Can I do this? Search for a face using face ID. My collection, count, faces found. Okay, so it's finding faces. Now we need to look through the collection. Okay. Yeah, let's do this. Search face in collection. So now we have our faces. Let's look for them in our collection. We have a family collection. So let's make a new, let's just say found faces equals an array. And then we're going to say found faces dot append. Match. We're just going to say match face and then face ID. I can type. All right, so we're appending that. Then, once we have that, if the length of found faces is greater than 0, then we're going to do this. Search faces in collection. So response equals search faces in collection. That must be where's this at? Right here. This is what we want. We'll make a new method called, we'll just copy this one. All right, search faces in collection, face ID, collection ID. We already know collection ID. What we're going to do is move this to the top. I may already have it way up here. All right, put it right here. All right, search faces in collection, threshold's 90, that's good. Client is that, response is this, okay. So collection ID we have, face ID we get from here, threshold we get, max faces is fine. Search faces. I just want to see the response. Okay, so we've got that. We should see matching faces, and this sure looks like the code we did before though, doesn't it? Search faces, and this is search faces by image. I really just want the names. I want to do Dynamo DB. Search for a face in a collection by using its face ID. Well, that's what we've done. So we're getting it from the collection. Maybe this will print the recognition ID though. Let's try it. All right. Found faces. Search faces in collection. Don't need that there. I don't need this. All right, let's go here. Response is that. Faces count. I'm not even getting that. I had to make it a little smaller. It's hard to understand what's going on here with all this, with the font too big. Okay, I really think there's something a little quicker we could do, or cleaner at least, but I'm trying to go fast to get this done in time for you. All right, let's start over at the beginning here. We get a face. or we get the image, so we take the image, we get it, we make it into a binary. We search the collection, so we search the faces by collection. If we get matches, then we start adding them to found faces. Now found faces we have, let's just see what we have in found faces. Print found faces. Start from there. All right, listening, and we're going to take a fun picture again. Now remember, we can what we will do is have an Alexa intent that says take picture, and all take picture will do, I'll show you in the skills kit, because we already have code that's real similar to it. Let's go to Lambda. So we'll add a new intent in the skills kit that will say take picture. So we'll say Alexa open Twitch robot, tell robot to take a picture, and then in our Lambda function we will be able to do this. Loading. Okay, so we will just be able to say send MQT instruction spin. Instead of spin, we'll say take picture. So this function is right here. And we'll actually need to change it. We'll have to make that dynamic. So we'll make the topic dynamic. So we'll say send instruction topic instruction, and then we'll change this up a little bit. So that's all we'll do. So we'll ask it, and it will take care of this part where I'm always down here taking a picture of myself or whatever. It'll just automatically take a picture. All right, let's see if we got it. Oh, out of resources. So sometimes this happens. So I've been doing a lot of breaks. I've been doing Control-C a lot. And what I'm doing is breaking out of it and trying to fix code and all that. What happens is it eventually takes up the memory on the camera. So you have to reboot the camera, reboot the whole Raspberry Pi. So I'm going to do that. We'll let that reboot. It'll just take a couple of minutes. All right, what do we have comment-wise? Good to make Alexa agile, pair programming. Yes, I agree. Good. We'll let that go for a little bit. We'll reconnect in just a second. So I've got some sample code that works. Let me find that sample code so you can see it. I wanted to do this live for you so you can see it in action, but since we're running low on time, I'm going to show you the code that I worked on already that has this part working, so it'll be a little clear as to what's going on. So we're going to let this reboot and then we'll get back in. Looks like it's trying to get back in right now. Twitch pair programming. Yes, that'll be really fun. All right, we're reloading the window. And I talked about this last week too. Code Insiders is really good if you work on the Raspberry Pis or remote systems you need to SSH into. This is really helpful. Okay, so here are the images it's been taking. I'm almost afraid to click it. Let's see what happens. It's not going to load them on this. I tried. All right, so let's go to our code. Let's see. I've got get checkout take a picture. Stash these changes. All right, here we go. This should work. So camera photo callback. This is the function we were working on. Here's one that should work for us. So the command's take picture, and here I was saving it to the temp folder. Detect faces I have a method for. Look up person by name. Here's what we need to do. So it's looking in a table name recognition, family, and friends, and it's getting this recognition ID. It's using the face ID. So we were getting that. I was just looking for the wrong key. So we were getting this face ID already. I just was looking for recognition ID. I thought that's what I was supposed to be looking for. I forgot. I got confused. So let's just run it and see what happens. Python Python listener. Oh, I need to go to the directory, don't I? What is it? Create workspace. Source, Alexa, source. There are the images, and we're going to do Python listener.py. All right. Oh, we have to do this little song and dance again where we go into the Pi and we start ROScore. Okay, ROScore is running on the Pi, on the robot. We're going to load the listener. I am going to take a picture, and I will show you this picture when I'm done, if it works. All right, took it. Let's go back here. Oh, session ID. Oh, that's okay. I know where this was. This was something I was working on for that. We're going to do this. I'm going to comment that out. So what I'm going to do though, once we get the picture, so let's say we get the picture, then we're going to have a table that has the Alexa session ID. So you've asked Alexa to take a picture. She takes the picture via the Raspberry Pi. We write a new record into DynamoDB with a session ID and all the people that were found. And that way she can see that and be looking for that and say, you'll say take a picture, and she'll say, I saw Jeff Nunn in the picture. So that's how you'll get her to identify what is seen. You could also do it, if you watched last week or the last 2 weeks, we did it with the Alexa Gadgets Toolkit. You could do it that way too. You could have a Bluetooth connection that uses a custom directive to send what it sees back to the Echo. All right, take another picture. Is there still a session ID? Oh. Let's comment that one out. All right. Close it out. Sometimes if you get a little too impatient, and if it's not closing for you, you can Control Z and then just do a kill on that process. You will run out of memory after doing that 5 or 6 times, but we'll do it today for speed's sake. All right, take a picture. There we go. So it found me, Jeff Nunn, recognize 1 people. Good. All right, so that worked. Let's try to see that picture now. So it saved it. Let's see, did it tell us where it saved it? Saved it this. All right. So we're going to go to C, desktop. Let me move this up so you can see it. There we go. SCP Pi at 192.168.86.25, and then the file name is that. And we're going to call this Here Goes Nothing. I have no idea what this picture of me is going to look like. I'm about to find out. And let's look with our old friend, Paint. There it is. That's me. It found me. All right. So that was that's facial recognition. So the next step is object detection and labeling. So I will add that. But what I'll do in the meantime is clean up all of this code so you can see it in action, and I'll give a good README like I have on the GitHub repo. So I think what I'll do is we'll just make a new section. It'll be, instead of connect to and drive, I'll add to this. So this one works. You can drive the robot around with your voice. I'm going to add a new section that says take a picture with your voice, and it will have at least person detection and maybe even object detection by this time next week. So that's that. If you have any questions at all, you can find me on Twitter at JBNunn. You can reach out to us on Twitter at Alexa Devs, or here on Twitch, Amazon Alexa. Follow me on Twitch at JBNunn. Any questions before we go? We've got about 5 minutes or so. So the main steps we did were to, let's just make a new file real quick. Take an image with PyCam, save the image locally, so save it to your Raspberry Pi, convert it to bytes, and send to recognition, and then search DynamoDB collection, or DynamoDB table, for the face ID you get back. So remember the face IDs it found here. Face ID here. And then you're just literally writing a very simple query. I'll show you that query in Dynamo. Right here. So it's just a get item. So you're using a get item on this table, and you're looking for that face ID. So let's go to DynamoDB items, and we're going to see if that works. There we go. So there's that face ID, and there's the name. All right, so let's see. Oh, some more ideas. Recognize Lego blocks, not to run the vacuum cleaner over. Yes, that'd be good too. You know, what'd be fun is to, that's a great idea. You could probably extend that to more than Lego blocks too. Special cases for toddlers, yes. So yeah, if you see a toddler in the room, that's a great idea, Jenny. So maybe you just abort. If you see a toddler in the room, you don't go in the room. Use the Pi to look for that. It would require you, I think. Well, the object detection and recognition definitely will do person detection. So yeah, it will see a toddler as a person too. I have a question about Alexa gadgets in the last session. How many connections can the Echo Dot handle via Bluetooth? It can handle one. I believe it's one at a time. That's a good question. The good thing is when you, let's see, Alexa gadgets toolkit Bluetooth number of connections. I believe it's one. By the way, did anyone get their invite for Alexa Auto? I heard they're starting to go out. You could definitely chase cats. iRobot has a skill for that too. So, yeah, Serge is right. They ride them. So I think the answer is one. E. Hernandez, I will get an answer for you on that one. Dog poo, yes, that was. I saw that story. So the I'm not going to train this. I'm not going to train mine. If you train a model for dog poo, I will love to borrow your model. I don't want to set that experiment up. But basically, the Roomba would run over it and smeared it. That was a fun one. Okay, let's see. What else did we miss here? I think I missed something earlier about Enterprise. For Enterprise version, iRobot once had it. Avoid, not disturb people who are in service personnel, so customers. Yeah, it'd be good. So maybe if you're in a store or maybe an aisle, you're cleaning. Yeah, I think what we're all coming up with are good ways to avoid, to have it do something when it detects people to avoid them, which is probably good for safety reasons. Special vacuum for the Legos only. It's a cleanup bot. I think it'd be great to to get the Legos out of the way so I don't step on them in the middle of the night. All right, these are great ideas. I love it. I think it's gonna be. We'll have a lot more ideas together too as soon as we get object detection working. And what I want to do is, in fact, let me show you this really quickly. This is kind of cool. So let's go to this. So there's a way to stream the video in real time. Let me see if I can find out real quickly. Yeah, right here. Okay, it's saved it. So let me see. I'm rotating. Okay, yeah. So I'm going to stream. So right now I'm streaming live from the video. I guess I could have done this earlier for you. This might have worked too. And you can use, it's just an RTSP stream. What is this? It's a new version. I don't want it right now. And we just open the stream. And it's listing, if you see here, on port. Well, I know it's on port 8554, which I have saved here probably. All right. So now we should be able to see everything. Let's see. Yep, there I am. So that's the camera streaming on the bot. Go back to robot cam here. You can see it. Well, maybe you can't as I move it around, but yeah. Can you see it? You can see that, right? Screen. Oh, maybe you can't see it. Yeah, there you go. It just took a while. Sorry. I see a little delay. All right, so that's it. That's streaming. But you can do that. What I would like to do is annotate that stream. So I'd like to draw boxes around everything that that are objects or people, and that way you can have them marked and then identify where they are and avoid them. Streaming via WebRTC, yes, you can do it too. I haven't tried that yet, but you can do that too. All right. Hey, I love the feedback today. Thanks everyone for all the good ideas. It was really good. Sorry my main camera didn't work, but you really didn't miss anything in there. So next week, I think we're going to continue on the same path with getting object detection working. And then we're going to finally get to, in the next 2 or 3 weeks, we're going to get to the third method with which you can communicate with robots. And that's building a microphone and speaker or just input and output directly onto the robot itself. So as you know, right now we're controlling things with an Echo device. But the third method we'll use is directly on the device itself. All right, anyone else have questions before we take off? If not, I want everyone to have a happy Friday, have a really good weekend, and then we'll see you next week. And then just follow us throughout the week. I'm going to start streaming more, excuse me, in the mornings on the Amazon Alexa Twitch, so you can join those and just see me fumble around there too. All right, everyone. Thank you.